Welcome to the Algebra Final Review. This is Standard 10 and Part 1 of Standard 10. We're basically going to break this standard into two groups, two videos hopefully. The first one we're going to talk about working from the tile patterns, and the second one we're going to talk about working from the rule and being able to graph it and determine it. All the ones in this standard are quadratics, and so it connects very much with Standard 9 that we've already done. Okay, one big idea that I want you to think about is when we were doing linear things, like this one in one of the earlier videos, notice that if I look at this one, it's going up by a constant rate. In other words, this has one tile in it, 3 tiles, 5 tiles. So each time I added 2 tiles to get there. So I'm adding the same number of tiles each time. And that's one of the things that's characteristic of linear kind of shapes. The other thing I notice is I'm just adding a few pieces here and there. And so that's another characteristic, not completely all the time, but will usually serve you well if you know that if you're just adding a few tiles here and there each time, you probably have a linear pattern. Now the reason I show you this is because I want to show you that when I do a quadratic pattern, once again, I'm interested in how many tiles there are in each figure and how the tiles relate to the figure number. So in this one, when I look, okay, I'm going to start by showing you. If I compared the first one and the second one, it looks like I'm adding, I'm going to put this here. These tiles were in the first one. And so it looks like I've added some here and some here. Okay. Here again, if I look at the second one, let's see, if I just color in the second one red, it had 3 across. Okay, when I do that, I see that once again it looks like I've identified a pattern of how it's growing. Okay, how many tiles are in this one? See, so let's see, there's 6, 7, 8. So there's 8 tiles in that. How many are in this? Let's see, 12, 13, there's 14 in this one, and there's 22 in this one. Now, let's see if it's growing by the same rate every time. Okay, this one grew from here to here. I added 6 tiles. From here to here, I added 8 tiles. Let's see if that's right. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So I see that I'm not adding the same amount each time. I'm going to tell you what the next one would be. The next one would add 10 tiles and would have a total of 32, because I know this pattern. And you can see that I'm not adding the same amount each time. I added 6 here, 8 here, and 10 here, but I am adding kind of a pattern. You can see that I'm going up by 2 more each time. When you see that kind of a pattern, it's probably a quadratic. Now, when we're looking for the pattern, I want you to remember this idea. I've drawn a rectangle here, and if I wanted to find out how many tiles are in there, I could count them all, or I could remember that I can find the number of tiles by doing the length times the width, or base times height. 3 times 5 is 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 tiles in here, and I found it by multiplying these two sides. That's going to be important for writing our rule. So let's look at the problem that they give us. And they ask us to examine the tile pattern and then write a rule to represent the number of tiles in figure X. And then if it's a quadratic, and how would we know? Anytime you're adding things that look like they're adding square, making bigger square, or a bigger rectangle, you're probably dealing with a quadratic. We're going to check this one by just doing the method we just talked about. So I'm going to look and see how many tiles are in this. 8. There are 10 tiles in figure 2. There are 1, 2, 3, There's 17 in that one. Let's see if that's right. 3 by 4 is 12. And there are 20, 21, 22, 23, 24, 25, 26. There are 26 in this one. Okay, let's see. Use just another color just to see what I'm doing. In this one, I went up by 7, and in this one, it looks like I went up by 9. So that pattern looks like it might well be a quadratic. And I see that my rectangle in the middle is getting bigger. Remember, when we look at these patterns, I like to think of like a body and the arms sticking out. Okay, so I've got a kind of a central here with some things on the side, and some of these things on the side looks like we got a little bit of something growing there. But so I've got a lot of different things going on in this one. So let's look at it and see how it relates to the figure number. Okay, I'm going to look at the rectangle. I see a big rectangle in the middle, and so I'm going to look at it. So I've got a rectangle kind of here. Okay, and so it has a dimension of 2 by 3. This one has a dimension of 3 by 4. And this one has a dimension of 4 by 5. Okay, now still got to take care of all the other stuff on here, but it looks like these two pieces on the side, they just seem to, looks like they always stay there. And at least for now, I think I'm going to just kind of pretend that they do, because I don't really know. But let's see. So I'm just going to put 1s in there, because they don't look like they really change. And then it looks like this one has 1 tile out here. This one has 2 tiles. This one has 0 tiles hanging out. So I've broken it into a bunch of different groups. Now, let's see if we can make it into a rule really quick. Okay. It is a quadratic, I'm pretty sure. But how does this relate? Well, figure 2 has 2, figure 3 has 3, figure 4. So if I was making a figure X, the center rectangle would be X wide. Now let's look at the height. This one had a figure number of 2, but it had a height of 3. Figure 3 had a height of 4, and figure 4 had a height of 5. So it looks like it's 1 more than the figure number. So that's going to be the figure number plus 1, or X plus 1. Then we had the pieces out to the side that didn't change. 1, 1, 1, 1. Okay. And then let's see what the red does. This had, figure 2 had 0, figure 3 had 1, figure 4 had 2. It looks like it's always 2 less than the figure number. So out here on this side, I would probably say this is going to be the figure number, take away 2. Now I need to combine all of these in their appropriate manners. To find the number of tiles here, I multiplied 3 times 4. 3 times 2, 5 times 4. So I'm going to multiply x plus 1 times x. Okay? Then I'm going to add 4, and I'm going to add x minus 2. The reason I'm not multiplying is the x minus 2 was always just 1 tall, pretty much 1 tall, so I know it's just going to be 1 times x minus 2, so we're just going to add x minus 2. We're going to simplify by multiplying it out, and let's see what we get. If I multiply this, I get x squared plus x plus 4 plus x minus 2. Combine like terms, I get x squared plus 2x, plus 2x, and those two go together, plus 2. And that gives me my rule, and so that's basically how we do that. We know it's a quadratic because it's growing with this x squared. The rule had an x squared in it, so we know that it's going to be that. We'll see you in part 2.